Hey guys, so my name is Krzysztof Zabłocki. I'm an iOS consultant, currently work with New York Times. We recently rewrote the main application in Swift, and I led most of the architecture decisions for that product. And I also do a lot of open source projects and run my own company when we make kids apps for entertainment and education. And today I'm going to talk to you about metaprogramming in Swift and a tool I created that helps us achieve that goal. So just to get started, what is a metaprogramming? Because there are different definitions and people look at it differently. So at university, the source of truth for passing exams was using Wikipedia to answer the professor questions. So let's look at what Wikipedia says about metaprogramming. So metaprogramming means that a program can be designed to regenerate, analyze, or transform other programs, and even modify itself while it's running. That's the definition, but what people usually use metaprogramming for is a little different, because in reality, it's used as a code generator. So you can avoid writing the same code over and over again. So you want to get rid of boilerplate, you start looking at whether your platform or language supports any kind of metaprogramming. So language that has a really great support for metaprogramming, which I am familiar with, is Ruby. It's part of the core of the language. It's really expressive. And as an example, if you have a class with two methods, and obviously for sake of the slides, those methods are really small. But imagine that you have two functions, that they do a lot of similar work, and there is just some parameterization there. So here the parameterization is whether it's a front end or a back end. So it's like just one argument. But in real application, that could be a structure describing multiple data points, right? And there are ways to do it just by passing configuration, but there are also situations when you want to generate the same code for different types that you cannot really reuse using the standard language functions. So you cannot use arguments. You actually have to generate the same kind of code for different types. For example, in Swift, that would be equality, where you cannot just have a function that generates it for you. So if you have in Ruby, if you have something like that and you notice, okay, there are some repetitions here, I would like to avoid this, it's pretty simple to change this code. So what you can do in Ruby is you extract the things that are different, you do a for loop on it, and you dynamically create a method. So for each of the argument, I define a new method. The method name is coding, and then the argument. And then the code looks the same. So I can write it once, test it once, write a test for this metaprogramming code. And if a bug is found in implementation and I fix it in one place, it's fixed everywhere. So rather than having to go into multiple source files and try to figure out where the repetition was, this is already taken care of. So why would we want metaprogramming other than that? What are good reasons that we want it in Swift, which is a very strongly typed language? So if we look at the way we work on iOS platform every day, let me just ask, how many people do iOS here or macOS? Right, so most of you. So our day-to-day job, right? Every day you come to office and you start working on new feature or a bug you have. And so what are some of the things that we repeat across all the projects? So it doesn't matter which project you work on. I bet 95% of people had to write equality for their structures or models. They had to write hashing, because if you want to put something into a dictionary, it has to be hashable. You have to do some kind of data persistence, otherwise your app won't work offline, and that's a common request from the product. Or you have to consume data, right? Like, isn't 95% of iOS applications or mobile applications in general just consuming some data and displaying it nicely? So we all have to do some kind of parsing. Either it's a JSON or it's some other form, doesn't really matter. And we also, if we do tests, that's not very common in iOS, unfortunately. But if we do tests, we need to deal with mocking and stubbing objects. And in Objective-C, we could leverage runtime to use libraries like Mockito, OssiMockito, or OssiMock. With Swift, we actually have to maintain all those implementations for tests separately. So if you have a protocol in your application and you want to change that protocol, you also have to go to the test target, update all your fakes, update all your tests. So it's a lot of repetition. All of those tasks, if we take them separately, are pretty simple. Like everyone that does iOS can write equality, and they won't have problem with it. There's a lot of them. This is just like a tip of the iceberg. There's so much more repetitions that we do every day. What's annoying for us is if we now looked at all the projects you guys are doing and we look at any of those things, we will find so much repetition. Like, it doesn't matter where the project is created, what kind of team is doing it, the code looks almost the same. The only difference is like property names and stuff like that, but the algorithm of it, which is what we do, right? As a programmers, we come up with algorithm. So the algorithm of all those implementations can be boiled down to the same code, the same description of the problem. So we keep writing this useless code instead of focusing on what really matters. Like, the user doesn't care that you had to implement equality or hashing or this or that. They want a fast performant app with a lot of features that are useful for them. So the idea of metaprogramming is to allow us to focus on what matters and not deal with something that should be provided by the language or the platform itself. So what can we do with metaprogramming? So we can avoid repeating ourselves. So whether I work as a consultant, I get hired on multiple projects. So I join one project and I see the guys are doing this implementation. Then I join another project and they are doing the same stuff. And it happens, like I worked on tens of apps and everywhere it's the same crap over and over again. Like, why do we have to repeat the same patterns? Why cannot we just solve it for the whole community? If it's always the same, there should be a way to express it. So we want to not repeat ourselves because this leads to problems, right? It's not very nice. So we want to write it once, define what equality means, right, in an algorithmic terms. Then test all the scenarios, all the use cases there, corner cases and all, and know that we can rely on this code. As the project grows, as we change the types and everything else, this should work. This isn't complex, right? So it will ease maintenance costs if we are able to do that. And it avoids human mistakes. And other than that, it also allows us to experiment with interesting architecture choices. So experimenting with architecture choices. Swift is very strongly typed. There is a lot of features, you have generics, you can use a lot of nice stuff, but there are also things that are missing. Like Swift doesn't have some types, doesn't have a lot of concepts that are available in other languages. But there are ways to leverage the compiler even more. If anyone ever tried using like protocol composition for dependency injection, it's a very useful thing to do. It allows us to ease maintenance costs when we do dependency injection in the projects. Or for example, if you use typed identifiers. So rather than an email being a string, you have a separate structure that ensures that you never pass something that's not already validated email into your API, right? There's a lot of things we can do, but it requires creating extra classes, extra structures, a lot of boilerplate. We want to be able to express something and then just have it work rather than having to maintain that boilerplate. So avoiding human mistakes is what I like to focus on, because implementing any of those repetitions is not a problem, right? It's very simple to do. But the problem isn't writing it. Anyone can write equality. The problem is that when you change the code that also has the boilerplate. So let's give you a scenario. If we remove a variable from a structure that has equality and hashing, the compiler will tell us, well, you forgot to update this boilerplate because it's trying to access variable that doesn't work anymore. That's great. What happens if you do the opposite? What if you add a variable? The compiler doesn't give you anything. Like, if you don't remember to update all the boilerplate, and the boilerplate isn't always in your type, right? Sometimes the code is an extension or is a factory somewhere else. It might be a completely different file, even module for that matter. And now the compiler doesn't tell you that there is a bug. And what can happen is something that happened to us. And if you don't realize you forgot to update some boilerplate, you will have bugs in production. And with New York Times, we do a lot of text display, right? It's a news application. We have a lot of core text rendering and stuff. And that's pretty expensive. Like, laying out text is probably the most expensive part of layouts in iOS, because laying out views, it's pretty simple. But how do you do word wrapping? How do we avoid images? All this stuff that takes a lot of time to compute. So what we do is, once an object that represents an article is calculated first, it's laid out first, we cache the necessary data. And now, every time this article appears again, we can look to the cache and get all the numbers rather than recalculating it again, which is great and saves a whole lot of time. And the problem is, like, I went to a conference, I was gone for a week, I come back and I get a bug report from production that the cells are clipped. So the text isn't fully visible. And now, what is the problem? So I look at the code, I spent some time debugging, trying to figure out what exactly broke, because hash collision is not an easy thing to reproduce, because it doesn't happen every time. Like, it's something that happens rarely. And for some reason, it happened for one of the users. And the bug report was from a couple days ago. That article already went away. So I have a problem, right? I reproduce it. I figure out, okay, this is the collision. That's the problem. So I look at the code and I see the diff for that class, and I see that someone added a new variable, but they forgot to update the hashing function. And now that bug, we only realized that there was a bug because the user did. And that's the worst time you can do, right? You want this to always be caught before, but it's really hard to do it if you have a big team. You cannot overview every code change, and people work under a lot of stress. There are crunch times. You cannot really depend on people not making mistakes or other people catching everything. So as much as you can, you should automate. And this is really hard to track. So what are some of the techniques in Coco that we have for metaprogramming? What is available by default? So we have some stuff that was used in Objective-C a lot, like runtime and reflection for Objective-C, or you can use it in Swift as long as your types inherit from an object, which also means you cannot use any of the Swift features if you do that. If you inherit from an object, you're losing a lot of the power of Swift. It's not value types, and it's not ideal, right? But it's really powerful. You also have key value observing, and you have key value coding. And those things, like key value observing again, and as object-based, key value coding and key paths are now supported in new Swift. Thankfully, they added support for that. But this is still, it's not even close to the power of Objective-C had. So the other thing you have in Objective-C is you could do metaprogramming, right? You could use swizzling, all this stuff. And a lot of people are afraid of that, and for a good reason. So a lot of analytics libraries, I'm not going to name it, you can all figure it out. A lot of analytics libraries work in a way that you include it in the project and it swizzles the hell out of it. And that's how analytics works. And it's all beautiful when it works, and it's very bad if it stops working and you have no idea why. Because there is no code that you explicitly ask it to do. It's just start analytics library and then shit happens. And we had things like some JavaScript core running in the separate thread that was destroying the CPU. It would just run loop forever, taking a lot of resources, actually heating up devices, lots of problems. You want to have more control over the code you are running. The other thing is, when this magic stuff happens, you want to be able to debug it, right? You want to know what's happening. And with runtime, as powerful as it is, there is no compile time safety. It's really hard to reason about. And you cannot just put a breakpoint and see what's happening because you swizzled 10 or 20 methods. So that's a little problematic. So what do we have in Swift? Well, most of those features are not available. So unless you inherit from Objective-C or you fall back to using runtime, that's going away. So with Swift, the only thing we really have is reflection, mirrors. And it allows you to learn a lot about your types at runtime, which is convenient, can useful be, but it's read-only. And that means that it's not very useful. Like if it's read-only, you cannot declare a conformance to a protocol dynamically. You cannot make your type, even though you know all the properties in your type, you cannot say, well, so I'm just going to use the mirror to implement equality. You don't want to do that, right? In theory, you could write a function that's using mirrors, and it's just a very easy way to get yourself into a lot of trouble. So don't do that. The mirror is useful if you fall back to Objective-C. So you could do property grids in Swift if you have the base class of NS object, right? You could use reflection to get a nicer API for reading what's there, but you still have to fall back to Objective-C runtime to actually modify it, or key value coding for that matter. So will Swift add more powerful features? So this is my discussion with Joe Groff, which is a Swift compiler engineer from over a year ago. And when I was introducing Sorcery, we talked about whether this is a good idea or not, and what are the plans for the Swift core team. And they wanted to add equality like Haskell does, and also macro support, but not macros like in C, more macros like in Rust, when you have like real AST-aware code that you can actually debug, not like C macro that just you put a breakpoint and there is like a ton code that executes at the same time, and it's completely ridiculous to work with. So they already added, like, actually part of the reason they added it, which wasn't planned for this like Swift 4, was because so many people started using metaprogramming, and so that pushed their priorities ahead, which is great. So we already have equality and hashing for most types. I don't think they finished all the implementation. They were still, like they had it for structures, and I think recently they did something for enumerations, but I'm not sure if it's like 100% done. So some of those features are landing in. So we have new key value paths, which is useful, and we have deriving equality and hashability, also codeable, right? And it's nice to have those features in the language, but now there's a problem. So we have derived equality, hashing, and codeable. Those three concepts, Swift can give you automatic implementation, except if you need anything else that's not like just one algorithm, right? If it's exactly all the properties, exactly all the keys match to their JSON counterparts, you can use codeable. One key is different, you're on your own. So if even one key in your JSON doesn't match what codeable uses as a representation, sorry, you have to write your own implementation for decoders and decoding. The same with equality. So if you have a property that's intermediate value that you don't necessarily need to compare for equality, it's like a cache value or something, you have to write your own. So there is no control over the derived implementation, so you cannot fine-tune it. So it's it's useful when you can use it. The moment you cannot use it, you have to implement everything. So there are problems with metaprogramming, though. In most languages, and including Objective-C, it's based on strings. So rather than using strong types, you have to deal with string-based API, which isn't good. It's very easy to create bugs. And there are no compile time errors because the code that it's executed on runtime, you cannot put a debugger to, like you can put a debugger to see some swizzled method, but a lot of stuff happens behind the scenes. It's not as explicit as normal code, so it's a little different experience. And because that allows you to create inconsistent app state, because if you mess up the runtime code and you run the application, it seems to work, then you run it on a different device and there's something wrong, and it's really hard to reason what's wrong. So it's very hard to debug. So do we need to wait for Swift 6 or 7 to have like more control? If they implemented the macro system, we could implement a lot of features on top of that. The macro system from Rust would basically feed you the informations about your types and allow you to generate more code, which would be pretty convenient. And it's also compile time in Swift. That would be the expectation. So Apple has a lot of priorities. I don't think this is their priority, even though we were able to push them for like equality and hashing and codeable as a community, because we showed them that there is a need for that, and like they kind of conformed, but there are so many problems that we need to fix before we should be focusing on those features even more. Like I would like to see better compile times, or not breaking incremental builds, because oftentimes I modify one file and I still have to wait 2 minutes to get the application to run. So there are much more important priorities for everyone in this community. So the tool that I created is called Sourcery, and what I do, I call the way I create, I have a lot of projects, and the way I create the open source stuff is, I call it pain-driven development. So because I get hired as a consultant to help multiple projects, multiple teams, and I see this team doing this team doing the same stuff, this team doing yet again the same stuff, it's really annoying. Like if I have to go to this project, and this project, and implement the same stuff, basically over and over again, like how many times can you implement equality? Like 200 types. Like in the Times app, we have, I think, 900 types. And now if I wanted to make everything equatable, I would shoot myself in the head. Like, it's ridiculous to have to do it, right? So because I saw those problems and I saw those bugs that come with it when people have to maintain it, I came up with this idea, right? So the way Sorcery works is it scans your source code, it builds abstract syntax tree, which is a metadata for all your types in your project, and then it runs it to your templating language of choice. There's multiple ones. And that allows you to generate more Swift code. Now, what's important to know, and a lot of people are afraid of adding a new library or a new dependency to their project, and for right reason, because every time you include a library into your project, you are responsible for being able to maintain that code. You are responsible for the side effects that that brings. If you want to include, for example, REST-Kit, you have to inherit from their base class. All your models have to inherit from their base class, right? The same goes with Realm and with other libraries like that, which is a big risk if you think about it. Because if down the line you decide, okay, so this isn't working for me, I no longer want to use core data, or I don't longer want to use REST-Kit, you're kind of screwed, because just inheriting from that class means that you have access to a lot of stuff in your project that now if you decide to rip it out, you will have like side effects of this. Making that decision will be huge. You will have to change hundreds of classes, hundreds of files, massive change, and you have to retest everything. It's very problematic, right? So Sorcery works very differently, because Sorcery is not a code dependency. If you decide to use Sorcery in your project, it doesn't add a single line of code to your project that you didn't ask it to do. The way it works is it's an application, and it works like a preprocessor. So the way it works, you run it before you compile your code. The tool learns about your types, it generates new code for you. That code is included in your project, but that code is exactly what you told it to be. There is no opinion there. Like if you want it to generate Swift, it will generate Swift. You can even implement bridging to Objective-C. So you can have if you have mixed source code, you can have Swift as your source of truth for like structures and enums, and have Sorcery generate Objective-C wrappers for it. And then you can use it from the legacy code. You can still call into the new code, which is very convenient. So it runs before your compilation phase. Everything goes through Swift compiler. So if you make a mistake in your metaprogramming template, you will get compile time errors. There is no runtime there at all. There's no magic involved. And so you have to think about it more like a preprocessor than a framework. And this is extremely powerful because the code it generates is pure Swift. It looks exactly as you want it to look. So each project can have a different code style, different flair, whatever they want, right? And the way it works, it's not solving just one problem. It's just opening the ability to solve multiple problems. Whatever repetitions you have in your projects, whatever boilerplate you have, this can help you get rid of it and limit the human mistakes with it. So what are templates? Because that's always interesting. So because we have to generate the metadata for your types, we need some way for you to write what you actually want to generate with it, because the data itself isn't very useful. You have to do something with it. So we support a very modular architecture. It's very easy to bring your own templating language. We have 3. And we have Stencil, Swift, and effective JavaScript templates. And so this is how a Stencil template looks like. And it's created by Kyle Fuller. It's a really simple language. It's one we default to because most boilerplate code can be expressed very simply. It doesn't require a lot of complex logic. And I recommend this for beginners because it just looks like Swift, very similar to Swift. It's much more limited, like you don't have that many features. You cannot do very complex templates, and it's for a good reason most of the time. But if you need power, we actually implemented like real Swift templates. So what you have here, what is in braces, that's real Swift code. What happens is we just extract this code. We have a helper for outputting the code. So the stuff you see in the type.name, that's just a helper that will turn into printing into the file. But this is regular Swift. So if you know Swift, you can just learn those 2 kind of markup, and you can start coding. What happens here is we get all of that code into a single file, and we run it through Swift compiler. There's nothing magical about it. That's all there is. It's a little slow because Swift compiler is slow. So, and you have effective JavaScript templating. If someone prefers JavaScript, you can go with that. There's lots of tooling for this, so people wanted some support. For us, it doesn't matter because it's so modular that it's like just a couple of classes that are added as a separate part of the application. And Sorcery also adds some features to your Swift source code. For example, actually, let me talk first about this. This is not us trying to reproduce how Swift looks like. We don't have to write the scanner for the Swift language. We use SourceKit, which is what Apple uses for Xcode and for all their tooling. So we build it on top of the SourceKit API, but we add additional parsing on top of it. Because SourceKit, for example, will tell you that there is enumeration in your file, but it will completely not care about the associated types. And we do, because we want to be able to generate code that does equality for enums, for example. So it helps. And it generates normal Swift code, no runtime, compiled, and fully typed, which is avoiding a lot of bugs. And what I really love is being able to program in real time. So I implemented a watch system for working with Sorcery. If you want to create new template or you want to learn how to do the templating, you can just run it in the daemon mode. And as you save the file, every time you save the file, it generates the code for you. So it can be used not just for implementing code, but also to learn about the types. Here I'm inspecting New York Times code base. And as you can see, I can see how many classes we have, how many enums, how many structures. And this is convenient because when I get hired to do code review for an external company, I can use my own tooling to first learn about the structure, whether there's a lot of value types, whether there's more classes. I could do a lot of interesting inspections. So it's pretty convenient. The other stuff it adds annotations to the Swift language. So if you ever work with Java or some of the other languages that have attributes, this is basically it. So with derived equality in Swift, you cannot say skip this variable for equality because I don't care about this, right? You cannot do it. The moment you want to do it, you have to implement your own equality and then you have to maintain your own equality, which is a pain in the ass, if you ask me. So with Sorcery, you can add annotations. You just do a comment, Sorcery, and then you can write multiple annotations. One can be skip persisting this or skip equality or whatever the template relies on. So it allows you to fine-tune your code. Or if you want to implement Codeable, you can just specify, well, actually this comes under this weird name in the server, and I couldn't change the server, so I want this to be nice in Swift rather than accommodate something that doesn't make a lot of sense. So it allows you to control the flow of your code generation. And it also supports inline code generation. So normally we do extensions. Normally we generate a separate file that extends your types. But for some things, you need to implement it inside of the original code. For example, if you wanted to implement NS coding, required initializers cannot be done in extensions. So you have to modify the file that defines the type. In Sorcery, you can just add annotation. And what happens here, when you run your template, the code gets injected into the source file. So very simple, very powerful. And either you can do it automatic. There is like an automatic function. So you can add it at the end of your type. It's just like in the tool, in the template, you can specify whether it's automatic or explicit. So either one is really convenient. So how do we integrate Sorcery? Like I said, build phase for your project. A lot of templates are bundled with it, which I'm going to talk about in a second. And working on new templates, definitely use the daemon mode. The live updates are beautiful. Like that allows you to create your boilerplate so much faster. So what are the bundled templates? So we already have implementation for equality, hashing. We have implementation for enum cases and counts. So if you have any enums in your project, you can iterate over them. You can see how many of them are there. So if you have an enumeration describing your settings, you can make a code that relies on that value being correct, and that Sorcery will make sure that if you add a new case, it will appear in your implementation. You can generate lenses if you like to use functional composition, which is very powerful. You can generate mocks and stubs for your tests. You can implement property level diffing, which I'm going to show you in a second. You can implement Linux main if your project works on multiple platforms, and you can implement decorators. And that's just some of the bundled templates. There are people implementing full JSON encoding. There is a project that implements like really powerful mocking, where it's called Swifty Mock or something like that. I tweeted about it recently. And it gives you the API you had in the Objective-C with OSI Mock, even nicer than that, and it's using Sorcery. There is a MongoDB persistence implementation using Sorcery. So it's crazy how much power this gives you as a developer to get rid of repetitions. And property level diffing, if you do TDD, usually have equality tests. If like sometimes you have primitive equality tests, but sometimes you actually want to have like a full object equality comparison. If you do it in Xcode in general, it doesn't matter what language, you will get this wall of text that prints one object and the other if it's not equal. It's ridiculous to be going to the log. It doesn't even show in the window, right? So you have to extend it, you have to look at it, and like there's 10 properties in one and 10 properties in the other, and now you have to find what's different. Very annoying. So if with Sorcery, when I was implementing it, it's fully test driven. So when I was implementing it, I didn't want to deal with that. So it took me like 20 or 30 lines of template to implement property level diffing. And in Sorcery, if you have a failure, this is comparing arrays of objects. So I have arrays of types that were scanned, and I can see that at index 0, there is an incorrect local name property, and the value was expected was foo, and I received boo-foo. So rather than having to manually scan it, I immediately know what's wrong. So extremely powerful. So big question, especially with Swift compile times being shit. Is it going to slow down my builds, right? I don't want it to be even slower. Like it's ridiculously slow for big code bases. So Sorcery not only does use SourceKit and fast parsing, it's much the way we have to parse the code is much simpler than what Swift has to do, because we don't actually execute the code. We just learn about the meta types. So it scans on multiple threads, it scans in parallel all the source files you have, and there is a consolidation phase that joins all the extensions and all this stuff that's common. So it's extremely fast. It uses extensive caching, and it's ridiculously simple. If the file didn't change, we will never read it again. There is no breakage of incremental builds like there is in Swift, because there is nothing that can change for our use case. So the cost, this is for running a really big code base, which is New York Times code base. It takes less than a second to deal with 864 types. How much does it compile? I think it's like 2 minutes to compile the project. So like less than a second increase. We wouldn't even notice if it was like a couple of seconds, less than a second, it doesn't really matter. So I'll show you a quick demo how the watch mode looks like. So let me just close this. Ah, sorry. And I need to change my mirror. Okay, so I can open Visual Studio Code. I have a project in Xcode that's open here. I don't need it right now. I just want to show you the daemon. That's like the nicest thing to look like. So I'm in the folder, and I have this YAML file that defines what Sorcery requires. So I specify the sources. It's not very visible. I have sources that just a folder name, and then I have where the templates are and when the code should be. So what I can do with Sorcery is I can run sorcery.watch, and now I can start changing the code. Actually, let me just put it here. So let's see. So as I can change the code, like as I type anything and save it. Can you see it actually? Is it visible? Let me just see if I can change the font. Preferences. Font size. Okay, is that better? Okay, cool. So I can see that how many types are in the project, and as you can see, I have a structure and a class here. So what I can do is I can add another structure just to prove that this works. This scans both your source code and your template, so it doesn't matter which you change. You can change both at the same time, and it will reflect the changes. This is not very nice demo, so let's do something else. So let's say I want to iterate over all the types I have in this project just to print them. So for type in types.all, and then I'm gonna end the for, and then I just want to print the type name. So now I have two. I'm gonna remove this one since I don't really care about it. I save this. Let's do something else. So for each type, I want to implement equality. So let's add some variable first, name, string, and then here, rather than doing this, I'm gonna do extension equality, and then I'm gonna implement static function equals LHS type.name, RHS type.name, and it returns a bool. And how equality works, we compare every variable. If the variables are different, it's not equal, right? And we return. If everything is successful, then we'd return true, right? So I'm gonna do another for each of the variables that we have. So I'm gonna do for variable in type. We actually don't care about computed variables. So you want to just do stored variables. Since that, for our use case, that's usually the case, right? The computed variables you don't need. So we end for, and for, oh, okay. And here I'm gonna do guard LHS dot variable name equals RHS dot else return false, right? So I have a variable called name, and like I mentioned it before, surname. If I added a variable, normally I would have to maintain the code. If I wanted to, what if I wanted to skip some variable? So if I have something like let transient and now this automatically picks it up because the template just goes over every variable. Let's say I want this variable to not be compared for equality or whatever else this template would be doing. So I can do sorcery skip equality, and then in my template I can do in type stored variables that are not annotated skip equality. Yeah, I save the template, the variable is gone. So the same, if I remove this and I save this file, the variable appears again. So extremely simple to add a support for annotations in your source files. And like the actual equality template that we bundle it's like 60 lines of templating because it deals with structures, it deals with enums, with associated types, so it's much more complex. But it works for basically almost any project you can have. So this is really powerful. I'm not going to show you the inline code generation since that's not that useful anymore. Like it's useful if you have like legacy stuff that has required initializers like NS coding. There's tons of templates. There's tons of tutorials for this. What I like about this experience of creating the template, when you can modify both the code and your description of an algorithm in real time and see the results, isn't that great? Like, I mean, isn't this how we should be programming? I actually have a tool, like a playground implementation for Objective-C that I did a couple years back that works in Swift and Objective-C. And just seeing the results in real time when you just save the file and you see the changes, that's such an amazing experience, and not the way we normally work when we change file and we have to recompile and redeploy the application just to see whether it took. So if we can use dynamic programming like that, it's really powerful. So it's available on GitHub. It's fully open source. There have been 40 contributors. It's not dependent on me. It's not like I go outside, get hit by the bus, and the project dies. There's now 5 core contributors, but in total, it's over 40 people now. There have been 40 releases of this, so this is moving really fast. We are adding a lot of features. It's very powerful, and it allows you to eliminate boilerplate, write it once, test it once, limit human mistakes, and ease maintenance costs. And all of that allows you to make better architecture, an architecture that has less bugs, that allows you to focus on what matters for your users and for yourself, for your sanity, because wasting days writing equality for oriel types, if you add the time together, it's such a waste of time. Like, you could be doing so much nicer stuff. If you don't trust me, there are people that like this is like I went to, that was like a while ago when I did recording of those things. Like, so I get Sorcery notifications on Slack whenever someone mentions it, and I think I have to disable it because I keep getting like a notification every day, at least 2 or 3 times. So, you know. And yeah, I mean, I'm open to questions. If you think that Sorcery is risky for you, or like you want to challenge me, I would love those kind of questions, because I think it's really hard to reason about why to not use it. So I would love to hear the counter-arguments. So if you evaluated it and you didn't decide to use it, I would love to hear why. So thank you, and we have a few minutes for questions.